Good morning, students. I am Dr. N. Sai Kumari from RMK College of Engineering and Technology, and we continue with the energy storage devices. Today, we are going to see a few facts on nuclear reactor. Now, what do we mean by a nuclear reactor? Actually, what happens in a nuclear reactor? Nuclear reactor is defined as an arrangement or setup which is used to convert a nuclear energy into electrical energy. What do we mean by nuclear energy? Nuclear energy is the energy which is produced by means of nuclear reactions. I want to recapitulate all the previous facts what you studied in your school days. Okay. Now, what are the two types of nuclear reactions we have seen so far? One is the nuclear fission, another one is nuclear fusion. Now, what do we mean by fission? Fission is nothing but it's a splitting up of single heavy nucleus into two or more lighter nuclei, and it is a spontaneous process. Spontaneous means it takes place on its own, and this nuclear fission takes place in a nuclear reactor. And the large amount of energy which is produced during the fission reaction is converted into electrical energy. So, thus, a nuclear reactor is the device that is used to convert the nuclear energy, which is produced by means of a fission reaction, into electrical energy. Now, what are the components of a nuclear reactor? And the components of the various components of the nuclear reactor are the first one, fuel rods, second one, control rods, third one, moderators, fourth one, coolants, that is a cooling agents. Next one is protective shield. Next one is pressure vessel and heat exchanger, and then turbine and generator. So we will see the components and their role one by one. Now, what are fuel rods? The fuel rods are nothing but these are the strips or rods usually made of radioactive materials like uranium, otherwise polonium, uranium 235, otherwise plutonium 239. During the fission, actually, a large amount of energy is produced at the same time. It involves the release of one or more neutrons. And these neutrons once again bombard with the uranium nucleus, and it makes the fission reaction a self-continuous process. And this is because of the chain reaction mechanism. So the fuel rods are nothing but radioactive rods like uranium and polonium, which undergo fission when bombarded with slow moving neutrons and release in turn number of neutrons and the excess amount of energy. The next one is a control rod. What are control rods? The control rods are side by side placed with the fuel rods and suspended from a platform. So you can insert the control rods whenever you want, and you can raise up the control rods at the same time whenever you want. You can lower it into the reactor and you can raise it away from the reactor. That is from the core of the reactor where the fission reaction takes place. And the control rods are usually made of cadmium, boron, etc., which are capable of accepting the excess neutrons. And we know that the main form of energy during the fission reaction is the emission of neutrons, and that set up a chain reaction. So once you absorb the excess neutrons, in turn, a chain reaction is controlled, and you can use the energy which is produced in the reactor constructively. Next one is a moderator. And moderator is used to moderate the velocity of the neutron which is ejected during the fission reaction. Actually, when you want to continue the fission process, you need only slow moving neutrons. But the neutrons emitted during the fission is at a higher energy and also moves with a very high velocity. Hence, the moderator is used to reduce the velocity of the ejected neutrons to one fourth of its original value. So commonly the coolants are used as the moderators. In some cases, you can go for graphite also. Next, very important component is a coolant, a cooling agent. Commonly, light water and heavy water is used as a coolant in the light water nuclear reactor or commonly nuclear reactor. And this coolant get into the reactor through the inlet and it absorb the heat in the form of a radiations and comes out of the reactor and it's converted into a steam. And the next one is a heat exchanger. In the heat exchanger, actually, the heat energy is released or it is received in the form of a steam turbine. And the heat energy, the form of a steam, is used to rotate the turbine. Therefore, the heat energy is manipulated into mechanical energy. And then generators. Generator, it converts the mechanical energy into electrical energy. So now to sum up, what are the various components of the nuclear reactor? Fuel rods, control rods, moderators, coolants, then fire extinguishers, turbine and generator. And the whole core of the nuclear reactor is placed inside a vessel that is known as a pressure vessel. And the pressure vessel is a container that is used to withstand a pressure of about 200 kilogram per centimeter square because to make the fission process a more commercially profitable one, they used to load tons and tons of uranium in the reactor and the fission reaction takes place continuously to make the whole process profitable. So the container or a vessel which holds the core of the nuclear reactor should be a well equipped one to withstand the heavy load as well as the pressure. And surrounding the pressure vessel, we have a shield which is known as a protective shield and that is used to protect us from the harmful radiations which comes out of the nuclear reactor. So commonly the emissions from the nuclear reactor is usually they are highly radioactive and we know the effect of radioactive emissions, otherwise radioactive radiations. Hence it is very important to protect us from these radioactive emissions. Okay. Now, when you come to the working principle of the nuclear reactor, actually what happens in the nuclear reactor, we have a core and the core consists of a number of rods which are made of uranium 235, otherwise plutonium. And they are allowed to bombard with the slow moving neutrons and the fission reaction takes place. The number of neutrons have been controlled using the control rods. And because of the fission, a large amount of energy is produced. And though in the heat exchanger, the energy produced, the heat energy produced is converted to steam. And the steam is used to rotate the turbine. And thus, heat energy is getting converted to mechanical energy. And in turn, the mechanical energy is getting converted to electrical energy out of a generator. So students, this is a working principle of a nuclear reactor and it's one of the highly repeated question during the internal exams. So please take care. Thank you.